number 1 in our sample-free response. And it tells us in number 1 here, part A, that the particle travels in an xy plane with equations x of t equals t cubed plus 5. Y of t is 4t squared minus 3. So we're given a set of parametric equations to describe the motion of this particle. And in part A, it says for time 5, find the velocity vector and its magnitude. Okay. So for part A, we got time 5, and we want to find the velocity vector and its magnitude. Okay, we know that the velocity vector is going to be the derivatives of each of the two components for x and y. So we should have got 3t squared and then 8t. Okay. So that ultimately would be the velocity vector. And the other part here says and the magnitude of the velocity vector. Okay, remember the magnitude of the velocity vector is going to be the square root of these two squared added together. So we'd have 3t squared plus 8t squared square root. And if we put in our 5 here, we're going to get 25 would be 75 squared. And 5 here gives us 40 squared. And keep in mind this is in the calculator part here, so if we didn't want to spend a bunch of time on arithmetic, just calculate it. So 75 squared, 7225. Turns out to be a whole number, which is convenient. And that would do it. Questions on part A? Alright, they do not give a point breakdown on this. After we get done, I'll guess what the points would be for you, and we'll see if we can agree. The one thing too, they reading the question again, they ask us for time 5, find the velocity vector. So the actual answer here should be those actual numbers, 75 and 40. Is it at time 5, what's the velocity vector? This would be the general velocity vector. So at time 5 should be that. Alright, and the next part. Part B says find the total distance traveled. That is the length of the path traced by the particle during time 0 to 5. Okay. Again, we know that that's an integral. And it's going to be the integral from 0 to 5 of the square root of. And in here, we're going to have dx dt and dy dt. So for us, that'll be the 3t squared and the 8t. Alright, so that would be our distance traveled. And ultimately, if we punch that in, looks like it should be 163. See if that's a fact. So that'd be 9t to the 4th. And bingo, 163. Good. Alright, questions on curve length, parametric equation, curve length. Alright, and on part C, it says find dy dx as a function of t. So if we want to find dy dx, we know in general that dy dx is equal to dy dt over dx dt. And dy dt is 8t, and dx dt is 3t squared. Found those above. So therefore we'd get 8 over 3t. Alright, and then finally, part D, d squared y dx squared as a function of t. Well, if we know the first derivative, we can find the second derivative. So ultimately we need quotient rule here. So 3t times 0 minus 8 times 3 all over 3t all squared. And negative 24 over 9t squared. Oh, I missed something. No. Say it again. Oh, you're right. You're right. Sorry. Out of my mind. Yeah. Ultimately, yeah, for the find the second derivative. Sorry about that. We're doing a straight second derivative. We ultimately this is going to be part of it, right? Okay. But for what has to go on top? Remember, dy dx is going to be part of it. There you go. Alright, so it's the derivative of this. So we just found that, so we do need that after all. Okay. And then it's going to be that over dy dx. So if it's over dy dx, then it'll be 3t.
It's just straight up over dx.
Over d.
It's just dx dt.
No, I forgot.
It's just over dx.
Let's look and be sure.
Yeah, no, it's over dy dx.
I think it's dy. Yeah.
It's over dx.
It's definitely over just dx.
Here it is. Yeah, ultimately the second derivative is the definition right here. So our second derivative is going to be the derivative of y prime, okay, which keep in mind is the derivative of dy dt, right, over dx dt. Okay. Alright, so let's try that. So the derivative of dy dt ultimately is start over again. So it's dy prime dt divided by dx dt. So bottom line here is that if we go dy dt, that dy dt is going to be the yeah, and actually that dy dt is the derivative of what we found the first time, derivative of dy dx. Yep, there we go. Okay. Remember, so that is that negative 24 over 9t squared then. So that's the derivative of what we found. And then divided by dx dt, and our dx dt was 3t squared. There we go. So that's the right analysis. So, all right, so in review, again, that second derivative is always going to be the derivative of what we just found. Okay. So the notation's kind of weird here with the d prime y that they use, but bottom line here is this just represents the derivative of what we just found divided by dx dt. And so if we do the math on that, we're going to wind up with negative 24 over 27t to the fourth. And these two can be reduced to 24, and the 27 can be 8 and 9. Negative 8 over 9t to the fourth. There we go. So it should be negative 8 over 9t to the fourth. I think that agrees. Yep, good. All right, so again, one more time. So we're going to find the second derivative, find the first derivative as such, dy dt over dx dt. Right, and then the second derivative is always going to be the derivative of that, right, divided by dx dt. Okay.
Wait, is that 9t to the fourth?
Yeah, 9t to the fourth. Because ultimately we had 9t squared divided by another 3t squared. So negative 27t to the fourth. All right, yeah, point breakdown for this. Hard to say. I mean, I guess this is probably worth 2, one for the integral, one for the answer for that part. And the first part, I would say that's probably worth 2 also, one for the vector, or one for the vector and one for the answer. This first derivative one is a pretty easy question. I would think that'd only be worth 1, but maybe it's 2, I don't know. Bottom line is we've still got 5 more points to get out of all this, which yeah, it's hard to say. One of these probably has to be worth 3, so maybe the first one was worth 3, and the other ones are worth 2 each, maybe. reasonable guess. Okay, so we'll